Welcome to the class on series and parallel circuits. I'm Laura Lewis. Let's get started. So learning aims today, understand how series and parallel circuits are drawn. Number 2, describe how current is the same everywhere in a series circuit. And number 3, explain the brightness of bulbs in series and parallel circuits. Okay, so I'm going to start by actually drawing it. So you may have drawn a battery or a cell before. So I'm going to draw a battery. So batteries consist of 2 cells. Okay, here's a battery. Okay, battery. I'm just going to draw a really simple circuit with a battery and a bulb. Okay, bulb. So battery and a bulb. Okay, so a series circuit, this is just to demonstrate what a series circuit looks like. I'll draw another one in more detail in a moment. So series circuits have 1 loop. So 1 loop. Okay. So a series circuit has 1 loop. So the electricity goes positive to negative. So it flows all the way around. Okay. And then it comes back to here. Okay, it's just 1 loop, so it's just got a bulb in it. So parallel circuits. Parallel, all the L's in parallel, remember somebody saying. I spell parallel circuits. So parallel circuits, so we'll draw the battery again. Okay, and it sort of starts out the same. Okay, with the bulb. It doesn't really matter what component you put, I'm starting with the bulb, we'll use other components at some point. Okay, so 2 bulbs in parallel. Okay, so parallel means there's 2 or more loops. So parallel, 2 or more loops. Okay, so if we had another one, we would have 3 bulbs in parallel. Okay, 3 bulbs in parallel. So let's have a look. I'll go back, I'll draw a series circuit again. So how does current vary in a circuit? So in a series circuit, let's just draw the series one again. Okay, 1 loop, bulb, put that there for a moment. Okay, so in a series circuit, if you measure the current here, so example, we measured it as 1 amp. Okay, it is the same everywhere in the circuit, 1 amp, everywhere. Okay, through the components, also 1 amp. Okay, so in a series circuit, current is the same everywhere. Okay, so in a series circuit, current is the same everywhere. So that's what happens in a parallel circuit then. So let's draw, oh, it's a bit big, I'm going to draw this so it's a bit easy to see. Got a battery. Okay. 1 bulb here. Okay. Another bulb. You've got 2 bulbs in parallel. Okay. So these bulbs are identical. That's important here. That means they are exactly the same. Bulbs are identical. Okay, so example, say if the current was 2 amps up here, what actually happens is if the bulbs are identical, it splits evenly. Okay, if the components are identical, it could be things like a motor, it could be resistors. Okay, if the components are identical, it splits evenly. But then when it comes back together, it returns as 2 amps. It comes back together, so it splits evenly. Okay, it splits evenly if components are identical. Okay, components are identical. So let's just get a new screen. Okay, so for the brightness, okay, so brightness of bulbs in series and parallel. So you may have seen this in class in reality. Okay, so the first one, let's just draw a cell. So that's actually on its own, that's called a cell. Okay, let's draw 2 bulbs in series. Okay, okay, so then I'm going to draw the bulbs again in parallel. Okay, so what actually happens is in a series circuit like this, you've got 2 bulbs. So what happens is that the voltage is shared amongst the bulbs. Okay, voltage is shared amongst the bulbs. Okay, so they actually appear quite dim. Okay, but in a parallel circuit, okay, so voltage, okay, is going to be the same for each bulb, because these two could actually have different voltages across them. So one could be a little bit brighter than the other. You don't have to worry at this stage about calculating it's called a potential difference, that divider between the two. Okay, but in a parallel circuit, okay, they actually stay the same brightness. They stay the same brightness. Okay, as just one bulb. Okay, so you probably can tell then that most in reality, so in sort of a house or business or anything like that, most things will be connected in a parallel circuit. Also, a thing to say about parallel circuits, okay, is that if there was a break in the circuit here, this bulb would stay on. Okay, so if this one got broken, this would still stay on. Whereas if there's a break in the circuit here, or this bulb was completely shattered, that would turn off because it'd be a break in the circuit. So parallel circuits are a lot more practical in reality, and most things in your house will be connected in parallel. Okay, thank you for listening to this class. Hope to see you in a different one in the future. Thank you. Goodbye.